In my previous two videos, I talked about different mechanisms that deliver wind into the pipes, but I haven't gone into detail about the pipes themselves. Before I made this video, I still had some questions. I wondered how flue pipes produce sound without any moving parts, why stopping the end of a pipe causes it to speak an octave lower, and what all the different shapes of resonators really do in reed pipes. Let's start with flue pipes. This is a generic, unstopped wooden organ pipe. If we open it up, we can see the internal structures. Let's see what happens just below the mouth of the pipe. A small gap allows a thin sheet of wind to pass onto the pipe's upper lip. The wind must decide whether to enter or exit the pipe. If it exits, it creates a low-pressure zone that sucks air from the pipe. However, this suction force pulls the sheet of air inside, causing the outside air to be sucked in, causing the sheet to once again be pulled outside, resulting in rapid, random oscillations. When air is sucked in, it creates a pulse that travels up the pipe, exits at the top, and leaves a low-pressure zone that sucks in air from outside, creating another pulse of wind. This wave of pressure travels down the length of the pipe and also affects the sheet of wind, causing it to oscillate at a specific frequency. If you listen closely, you can hear a sort of white noise right as the pipe begins speaking. This is the random oscillation before it settles at one note. The opening at the mouth and the top of the pipe create opposing pulses of wind pressure, forming half a cycle of a standing wave inside the pipe. These points at the tip and the mouth, called nodes, have constant wind pressure because they are exposed to open air. The wind pressure in the rest of the pipe is what oscillates, producing sound. This is why longer pipes make lower sounds, while shorter ones make higher sounds. The reason that stopped pipes speak an octave lower is because there's only one node, so the standing wave goes a quarter of a cycle up the pipe and does the next quarter reflecting down the pipe. In other words, in the same space it takes an unstopped pipe to fit half a cycle, a stopped pipe stretches the wave out to only a quarter cycle. Reed pipes are a lot more intuitive. A reed pipe's base has a tube with a slot called a shallot. A thin metal piece called the tongue sits on top of the slit. When air passes over the tongue, it vibrates because air pushes it out of the way, and the metal tongue springs back. With this mechanism, the pulses of air through the pipe are caused by the reed physically moving out of the way. The pitch of a reed pipe is determined by the length of the vibrating section of the tongue, not the resonator. If the tongue is short, the pipe speaks a high note. If it's long, it speaks a low note. Different reed pipes have different shaped resonators because they produce different overtones. Pipes don't speak a single frequency. They actually speak at multiple different frequencies that all work together to make each pipe sound different. The differently shaped resonators between an oboe and a vox humana are what make them different. Inside the boot, they are essentially the same. I hope this video was easy enough to follow and that you learned something new. Until next time.